Everyone. Just a warm welcome to everybody who joined us today. I still see people coming in, that's awesome. As you know, we have a quite interesting subject today, and I'm happy to welcome Patrick Pongratz as well. Hi, Patrick.
Hi, thank you, Stefan.
How are you doing? Busy day today?
Yes, well, it was a busy schedule, like always, over the last 6 months. So COVID always means staying at home, working in one video session to the next one conference call for the next one. And so starting very early in the morning without breaks, that's some kind of challenging sometimes.
Yes, I believe. I mean, we become experts in working at home, right?
Definitely.
I'm in the lucky situation that actually my living place and my home office, so to say, is my office is at the same building. It's just in our store, and that makes things much easier for me in this case. So coming back to what we actually would like to talk about today, can you stop sharing for a second?
Stop sharing, yes, I can.
Yes, just stop sharing just for a second. As you mentioned, as you remember, we have the same person as a question: fraud detection, finance, or public sector, which is our subject today. And it actually refers very much to things I see on a daily basis as a problem coming up in my daily work as well. Since we work with text data, for example, and we look at entities to that kind of entity extraction using NLP and ER models. We always have a problem if you find some names in different texts, are we still the same person or not? This is, I think, the most easy part to think of how such problems might occur with people names and are those people the same person. There are more specific cases, as we know, in the public sector and also in the finance industry. And this is actually one of the things Patrick brought with him today. And I'm really listening forward to what he's going to say here. Patrick, do you have some short stories, anecdotes you can tell us? How long does it take to do that kind of fraud detection? Is it something which takes weeks or days, or what is it?
So it's a permanent learning system. So that is why we present something like this in combination with artificial intelligence, because I think it's not done at a specific point, because it's a little bit like the race between the rabbit and the hedgehog. You know, if you look for criminal intention, somebody is always ahead. So either you are ahead or the fraudster is ahead, and it's always like it's leveraging something. I want to give you one example. So some kind of fraud-related topic together with artificial intelligence and network analysis comes up when you look at VAT carousel. So, and VAT carousel is quite a common crime in Europe, but it's something where you don't save money. So if you avoid VAT carousel, it's still the same money than before, but the stuff is, so there is a lot you can do around that. And we're working on a project in Belgium for quite a long time. And so we avoid a VAT carousel amount of money comparable with 1 billion euros annually, which is quite a high number. But what I'm even more proud of is that we have a likelihood to find the right cases with more than 94%. I guess that is an incredibly high number. So now you might ask me, what about the last 6%? And it's exactly that. It's the race between the rabbit and the hedgehog, the fraudster and the investigator, to find new cases, new slots, new opportunities to be fraudulent, right?
Interesting. I don't know if you might have seen, I've started a survey, a quick survey among the participants who are still joining. I just wanted to know a little bit more about the experience we have. So the first question was, how experienced are you in data science? And 45% are novice, so that's just nice to know. we have 34% advanced data science. So this is quite interesting. And also wanted to know a little bit more about one of the subjects you have in your presentations today. One of the methods, it's network analysis. And indeed, 74% are just novice in the field. So I think it's quite good to know that, since you're just introducing, I think, a lot of methods as well.
Yeah, so I can do it a little bit more in detail. So my presentation is quite full of details, and given the maturity of the audience, so there would have been the possibility to skip some stuff, but I guess I can walk you through to everything, and everybody then gets a feeling for really what is network analysis, what is the opportunity behind it if you work with analytics within networks.
Oh, yeah, okay. So since we have some gurus as well here, I just wanted to let you know, stay tuned. Patrick will come up with the use cases in the second half of the presentation. So even if it's just introducing in some kind of method we have already heard, don't worry, we're getting into the details of how to apply the stuff later on. And yeah, I'm just curious now to listen to you and to see what you have to tell us.
Okay.
Patrick, it's now your floor.
Thank you, Steffen. So then I start screen sharing again. So now you should see something.
Yes.
Great. So the idea is to tell you something about how to identify hidden networks. So relations between people, entities, and I will explain what we mean with entities within the next couple of minutes, and then come to the combination of network and network analysis in combination with other analytic tools and ways of analytics that you might know from other use cases or other scenery. So first of all, I have some kind of an agenda for you. Why using networks for identification is the first question that I want to ask you, that I want to answer to you. Then I want to make a little step in between to show you from raw data that you get, how do you come from raw data to a decision via usage of a network. Then we will talk about intelligent separation of information objects. Then I will answer the question how analytics and AI fit together with network analysis. And I will end up with some intuitive handling examples. I have some examples for you, and we'll sum it up in the end. I'm happy to answer some questions as well. So first of all, why is it necessary? Why is it feasible to use networks for identification of people? So
just a quick reminder before we continue, just sorry Patrick for just interrupting you again. Again, if you have questions, if you think something you'd like to get more information about, or you did not really get what Patrick was saying, just don't hesitate to ask a question. I'm looking at the Q&A section. You can click on the icon, ask your questions, and I will take care that they will be answered. Thanks.
Great.
Sorry, Patrick.
Great. Thank you, Steffen. So the usage of networks is some kind of a model or an opportunity for risk assessment. And you can either use that in finance, obviously, but I will focus more on some public related topics, and you can adopt it to finance easily, because we work with similar use cases in banking and insurance as well. So the key drivers definitely is that, and you know that, I don't have to explain it again and again, there is an increased number or amount of data, as well in complexity and in volume. So it's just increasing day by day, and therefore it makes it harder to find the needle in the haystack that you're looking for. So plus there are a lot of regulatory requirements that are increasing. You know about the EU data protection and regulation scenario, which is only one aspect that you might consider when you use networks. So therefore, it is one possible outcome that risk assessment by artificial intelligence is a popular option, right? So, and on the other hand, while there is some technology increasing, like artificial intelligence, some other stuff is not appropriate anymore. So for example, the usage of simple business rules was some kind of adequate in the past, as well as the usage of statistical models. But that is not appropriate when you talk about network analysis, because simple business rules don't fit, and statistical methods are some kind of blind to the network structure, so you won't find them. And larger correlations are difficult to recognize if you have a lot of networks, but we will come to that within the presentation as well. So the question, why identification with network? It's quite easy. By linking entities, and I will explain what I mean with that. Previously, unrecognizable structures can be recognized and evaluated. So first of all, I want to make a little bit clearer what methods you might use if you look for fraudsters, for example. And so there is a different range from the offender's profile, if you wish to explain it like that. So there is the more casual offender, which has a more optimistic approach. Then you have single offenders with some kind of intention, so they do that more often. And then you have the really intentional fraudsters or offenders that are mainly organized in groups. And that is especially what I want to talk about today. So if you look about the tool set that you might want to use, rules and regulations is quite feasible for casual offenders and single offenders with intention. Search in databases is something that is appropriate. Anomaly detection goes more than into the more advanced stuff, so single offender with intention. But if you really want to talk about organized groups, then network analysis is mainly the key driver. And in the end, it's the best way to combine all these methods together to find what you're looking for. And that's some kind of the outlook and the summary that I brought with me today, and I want to show you. So first of all, the question is from raw data to decision via network. How do you do that, and what opportunities do you have around that? So first of all, it might be helpful to explain what exactly I mean with a network, or what a network is. And I really reduced it to the essentials by a simplified Wikipedia explanation. So it's honestly nothing more than the combination between some nodes and some edges. So a graph is organized by this, and I can show you what I mean with this. So the structure of a network really consists of raw data, and raw data might be, for example, your surname, your pre-name, your telephone number, your address, your house number, your credit card number, and all that stuff singularly viewed is something that we call raw data. And from raw data, we want to combine this to nodes that consist together or might have some kind of similarity that you want to look deeper and use as a combination. And in the end, if you combine then edges and nodes, you have some kind of an unstructured network, or a network that relates to each other. And you can see some kind of first correlations, first structures within your previously raw data. So network analysis, when we explain it in detail, so for edges and nodes, the key fields are real entities like names, date of birth, passport numbers, and the combination to generate these entities. So it's the combination of several raw data that makes an entity. So for example, the combination of your first name, your last name, your date of birth, or maybe your address together and combined defines a person. And that is what I mean when I talk about entities within my presentation and within the next number. And the connection between those entities need to be checked if they really exist and if they are relevant for what you're looking for. And so there is, for example, the possibility to divide your entities into the time-based segments, so for addresses and phone numbers, for example. And you really need to look a little bit deeper into these entities, because you will see what I mean with that in some slides. further, because if you don't bring some kind of knowledge and intelligence into these networks, it's just like one huge ball, right? So, and for the evaluation, so usage of generated networks with scoring models is definitely the way to go, and what makes sense. So there is an additional value to increase the precision of these prediction models when you put some kind of more analytic related content into that. So first of all, I want to show you some kind of an approachable way. What you can see here is a combination of documents, and documents can be nearly everything what comes to your mind when we talk about documents, then some kind of attributes. So for example, a passport, a phone number, some kind of your IBAN number or something like that. That helps to visualize the first network or the first relation to each other. It's very simple to build because it's very easy to relate to each other, but the challenge is it does not represent the real entities. So two data files on Max Mustermann might not exactly be the same kind of person because as I pointed out before, there's an increasing number of data, an increasing number of data collection, and one Max Mustermann is not necessarily the same Max Mustermann than the other, and therefore it might be feasible to have a different approach, and this different approach is the entity approach. So this represents real entities within data, provides accurate networks and assessment, but it's more challenging to combine that and find out what really relates to each other.
One question, Patrick, because the concept of the entity is quite important to understand the whole thing. So an entity is, the entity is, Max Mustermann is not an entity, it's a value, right?
Yeah, exactly.
And the entity itself, that would be person, or what would be the entity?
So the entity is something, maybe we can park that for a minute, and then I show you what an entity is.
Fantastic.
Is that okay?
Yeah, sure. Go ahead.
So when you have just this approach like here with the attributes and everything that might be related to each other, then you come to a picture that really relates to the picture on the left, what we call supercluster, which is the outcome of loads and loads of connected data. So this picture is mainly what we need, what we see when you, for example, look for somebody on Xing or on LinkedIn. So everybody is linked to everybody within 6 connections. So that is, it's not a saying, you can prove that. If you look at LinkedIn or Xing, you can see that you are in a network to somebody. And the interesting thing is you might have never heard about this person before, but you share a network with them. And that is not an appropriate way to work on a network because it definitely doesn't make sense, right? So, for example, if you are on the street and you're detected as one group that was close to, for example, someone that is infected by COVID, it doesn't make sense to show all these people in the next week or the next 2 weeks that have been in combination or in relation to this person you met on the street. You need to combine that with more intelligence. So it could be, for example, that you have some kind of fever, that you have cough, that you feel not well. So that decreases the data to the more relevant stuff. And that is what we want to do when we talk about analysis and especially entities that relate to each other. So how do we do that? So it's a combination of several methods that decrease the network to the valid points. So there is a rule-based approach that you can say, for example, if somebody has fever, then put him into the COVID network. It is risk-based. So if you're related to a COVID-infected person quite often, so you share the same office, you saw him several times a day, or you met him several times a day, that is something. Then the structure is important and some kind of an egocentric approach that decreases the cluster, supercluster problem itself by 90%. So you can shrink it down to really the relevant stuff. So
just give an example, Patrick. Can you just go back for a second? Sorry.
Yes.
looking on it's quite interesting. Do you have an example of a risk-based method? What does it mean? What are you looking at, or how can you reduce complexity?
Yeah, so for example, a risk-based approach would be looking generally to, for example, terrorism. It's easy. So if you share a network with a lot of people, and within your network is somebody that is a known terrorist, then it's much likely that you get a higher score and a higher weight within several networks when you share a network with a terrorist, right? That is a risk-based approach.
Oh, okay.
Okay. So intelligent separation of information objects hopefully explains or is the answer to the question that you just raised. So looking to entities, you see here, there are two separate persons. So the person on the, so these are two separate identities, right? The person on the left is known as Clark Kent, while the person on the right is known as Superman. And if these two entities are combined because of related information, then we can see these two entities combined to these two identities combined are one entity that is related within my network, and I should look after this entity and not these separate identities anymore. And the next point that really helps us to decrease raw data and decrease identities and get more relevance within an entity is some kind of technology that we call a fuzzy matching algorithm. So what does it do? It splits data into its basic components. It removes unusual parts of the names and it transforms, for example, some kind of common language. So for example, if somebody called Joseph and the abbreviation is ZEP, so then the fuzzy matching algorithm is able to combine that as one entity, for example. There is some kind of phonetic adjustment. So if you write Philip, for example, with a PH, and sometimes you write it with an F, then fuzzy matching algorithm is something that can help you with that. And you have some kind of a sensitivity score. So with a matching code that helps you to combine several identities and make one entity as a related outcome. So for example, you can see here three different identities. One is called Josef Steigemann von Hülz, one is called Josef Steigemann von Hülz, and one is called Sepp Steigemann von Hülz. And if they have a high matching code in the sensitivity score, then there is a high likelihood that we talk about the same person. And the interesting part is when you have some kind of opportunity or possibility, and this is some kind of OR approach, we have this kind of quality related measurements in more than 30 languages. And that definitely then makes it more easy when it comes to standardization, like parsing, to pattern validation, like matching, to gender analysis, like identification, because we can really, for example, when you think about Russian language or Arabian language, it is quite difficult to extract that when you don't have some kind of technology that helps you to automate that and has some kind of a learning algorithm that helps you to combine these data and learn from that. So let me give you one example. You see here several people with several identities and several kind of raw data that might be comparable. So you have, when you look at the name, it's Matthias Schmidt with different pronunciations. So there is an abbreviation with M. Schmidt, and there is the first name missing. Then you have different data sets that relate, for example, to the date of birth. You have some of them that relate to an address, so the street. You have the postal code, and for some you have a telephone number. And with this really different identifications and identities and raw data, with that algorithms that I just was talking about, you can say, okay, data about same object are different in the individual data files, but with different data sources. In the combination, it makes sense to cluster them. And that clustering here is, we build, for example, entities here. So this is the same entity. Then you have here some kind of the same entity. You have here some kind of the same entity. And in the end, you can say, okay, there is a very, very much high likelihood that we talk about the same person. And this person is exactly one part of the network, of the higher or the larger network scope that we are talking about or that we're looking at. So you can really shrink it down to some more essentials that makes your life really easier. So how to get entities? That is what I just explained. You have the raw data, you have several elements, then a composition is what I just showed in the red, with the red bubbles. So that is a composition. And this composition leads to entities, and entities lead to networks. So, and between all these steps are these phases of the analysis and then exclusion and combination. So you have a lot of raw data. From this raw data, you build elements, you analyze them, you exclude some stuff. Then you can make some compositions, you analyze that, you exclude some stuff. Then you build your entities, you have some facts and attributes and documents, and that relates then to your network and builds your network data. Which leads us to the question, how network and analytics fit together. So analytics and AI on its own is enabled to do some predictions on upcoming events based on historical data. The structure can be extracted from unstructured data like text and graphics. So network analysis mainly is something that helps us with visualization, because then we get it better. That is some kind of proven stuff. If you visualize something, it's easier to understand. And you have some intuitive capturing of the structures. And then in the end, you will need some kind of a combination and automation, for example, especially automation, to help you to make this network really a valid one with the insights that you can provide, the analytics insight that you can provide, the correlations that you can provide, and so on. So the way is entity creation, network features, and the feature can be some kind of a parameter as well. So a network can be some kind of a data source or some kind of a model itself, which then runs into analytics and KI as some kind of a special form of knowledge. So it's not necessarily that the network is it's your endpoint, because network then can be used as a model for your analytics, for answering your analytic questions. So in the end, entities and say social networks, if you generated them, they can use within your scoring models. So history of behavior, behavior within the social network, and information in the data files that are regarded. So that combined helps you to get a clearer picture. And then from the features, there is a derivation of characteristics from the network and the entity characteristics. Then the data can be added to document level for the prediction models. So that is what I mean with can be a data source as well. And with this featureization of the network, this is the analytics component that then can be used for the next step of answering questions. So you might stumble across some stuff within your network that has specific kind of importance or annotation. So for example, you will stumble across some kind of intermediate centrality, what we call betweenness. So there is a level where an possibly important node is located between other nodes in the network. So it's not very clear where you can put it to, or where you need to interpret it to from the neighborhood. So that reflects mainly a number of people or persons that are only indirectly connected, so the indirect connections. And that's important to know, because analytics helps you here with some rules, with some insights to either exclude or include them. So that has much to do with simplicity if you can reduce networks because of unimportance coming from betweenness. Then the next phenomenon is the proximity center, which we call closeness. So there's a difference between number of connections for each node divided by maximum possible sum of differences. And so the question here is how to define this closeness and how you explain it within an expanded community. So it's exactly the same question here. How would you do it manually? It's like some kind in the end of, whoa, is a gut feeling, put it in or put it out. Or you have some kind of knowledge, analytical driven, that helps you to automate that and then says, okay, causing the closeness of the proximity center, I might to exclude that or I might to include that. And then the last phenomenon is some kind of the self-factor centrality. So assigns relative ratings to all entities' environments. And here the possible usage is distribution of ratings to surrounded nodes based on the principle of high ratings. So you can give here some kind of importance of weight into the network. Like I explained it with your correlation maybe, or you're influenced by a terrorist. If you share a network here, you can give there some more weight into these networks, and then that gets some kind of a creational value. So,
quick question again, if you go back to previous slides, could you give me an example? Can you go back 2 slides? Yeah, so betweenness and closeness. If that sounds quite similar. What kind of question do you ask when you look at betweenness? And what kind of question do you like to get answered when you look at closeness of nodes in say maybe a real world setting? Does it really mean?
Yeah, so the betweenness is something that you consider with more or less indirect connections. So you have several networks, for example. How should I explain that? For example, with some kind of...
I think I get an idea. So one of the things we are going to analyze on a daily basis, lobbying structures, right? So say you have 10,000 articles and you extract the entities from those articles. Now we try to figure out what kind of people are near to other people, in the sense of we might be not directly connected, but could there be a chance that person A could have a contact to person B? Is that betweenness?
Yeah, that's some kind of the breeze. So I had some kind of maybe unusual example, but let me explain it to that. So we had policing, a law enforcement situation with one of the federal state crime offices, where we had some kind of a cluster of betweenness. So if you have 2 different rocker groups, so clans, like for example, the Bandidos and the Hells Angels.
Okay.
So the Bandidos are one network and the Hells Angels are a different network. You can't combine them because they're enemies, right?
Yes.
But there is a scenery in mixed martial arts. So kickboxers and ultimate fighters and so on. Yeah. They have a high likelihood to be part of one of these networks, interestingly. But often there is a betweenness. So people that are linked to mixed martial arts are in between these networks. So they are related to people from the Bandidos and they are related to people from the Hells Angels. And unfortunately, quite often they have some kind of a criminal background. And now there is the question, how do you put them and how do you recognize them? Do you want them to be part of one of these networks or do you want to exclude them? And if you include them, what is the value for these 2 different clusters within the networks? So is there an outcome or not? That is what we described with betweenness, for example. Was this some kind of understandable?
Yes.
Okay.
Was a good example.
Good. And closeness, yeah. So there's some kind of, you are not really part of a network, but you are very close to be fraudster, for example, when you have a lot of IBANs. And so, for example, you have an IBAN at, let's say, UBS, and 5 other IBANs at 5 other banking institutes. And within your area, so you live in a specific area, let's say it's Zurich, and within your street and within your job cluster and within your people around you, a lot of people with this UBS IBAN are some kind of tax fraudsters. When you are very close to them, even if you don't have any history in that. And the question then is, how do you want to define this role, and how do you want to expand the community of known fraudsters with a similar correlation to you as well? So you might be on a watch list when you are close to, for example, a specific network.
Yes, got it.
Okay. So in the end, what's the use of that? So an analytical network identification closes gap in the evaluation of data, especially for identification of fraudster schemes, and allows identification of suspicious activities previously unknown, right? So that is what we want and what we do that for. So to find the hidden relationships. And so the question now is, just network, does it help or does it not help? And the answer is no. If you build a network on its own, it does not bring you any value. So you need to combine it with some kind of analytic stuff. And now we are in the middle of the approach that I really wanted to explain you in combination with network analysis. So we discussed the levels of investigation coming from event entity to network, and now we want to combine it with an approach that I call hybrid analytics. So it's a combination of a lot of tools and a lot of analytical logic that you can bring into the evaluation of a situation and the evaluation of circumstances. So first of all, we talk about business rules, we talk about anomaly detection, about forecasting, text mining, the analysis of the social network. And here you see it's just one idea of the entire approach, and the database screening. And I brought you an example for that. So let's start with automated rules. Where is it helpful? So automated rules help you to gain additional insights to identify some criminal behavior. And the example here is that we talk about known patterns. So that is really the entrance level of analytics. In a specific time period, several invoices from one taxable person are very similar. Okay, that is an automated rule. I can work with that. I can apply that on other taxpayers, and then I might get an insight only based on rules and decisions. The second approach, and now we become a little bit more mature, is anomaly detection. So anomalies is the identification of anomalies and the aggregation, so the application to several clusters. So here we talk about the unknown patterns, and the example is there is a number of invoices of a taxable person that is significantly higher than in its professional category what the median is or the comparable persons are. So for example, there is a cashier at a supermarket store, and so the number of invoices in her tax declaration is incredibly much higher than everyone else in the same group. Then you have here an anomaly detection that you can use again as an indicator to progress. The third is then modeling. So here we talk about the classic analytic approach of data mining to identify new unknown patterns and trends. So it's the application of a specific anomaly that we have seen upfront to an unknown group of people. So what you have done with the anomaly detection, in the modeling, you apply on a high number of people. So we talk about complex patterns here. And the example is application of known use cases like the cashier to develop additional use cases based on available data and do a risk prediction. The next stuff that we want to add is, oh, that's wrong copied. So we talk about unstructured data here. That should be text mining. I'm sorry for that. So text mining helps you with analysis of free text and node fields to recognize certain models. We use that quite often, for example, in healthcare. So in healthcare, text mining is really valuable when it comes to prescription of drugs from a doctor. And so it's very easy to just screen all this declaration of symptoms, of history, patient history, and all that stuff. And you can see if, for example, this doctor is always prescribing the same drug from the same supplier. So, and here, that is, for example, some kind of increasement when we talk about free text and something that is just written and needs to be extracted. And what we do here in text mining is quite interesting. So we calculate the distance between words and the distance between the specific columns. So to give an indication if it's more positive correlated, negative correlated, what is the sorry, I missed the word. We'll get it in a minute. So with text mining, we really mean free text. And then you can match that with databases. That is quite easy again, matching of persons with available lists. And for example, when we talk about text fraud, then you might have heard about some known registers like the Panama Papers or internal blacklists like text CDs and stuff like that. So that is the combined approach that really makes the so-called magic. But I need to say that the so-called magic is not a black box approach. So it's not something that you put into some kind of an engine and then something like magic happens and you get an outcome. Everything of these steps is really, really approachable from the user's point of view and helps you to understand what have I done, what is the outcome here, and what does it have for an impact when it comes to really bringing knowledge into these areas.
Patrick, when I was just looking at the first two steps,
yeah,
your list, so automated rules and anomalies, I think the examples are quite helpful to get an understanding of what questions could there be, or what kind of things we could look at. Looking at the things you're just talking about here, like in a specific time period, several invoices for one taxable person are very similar. Are those rules not only automated, but are there somewhat built into the logic? Or do you actually ask those questions? Or can you say, tell the machine, hey, please find the patterns for me I might not be looking at?
So most likely we find a situation with customers where they have their automated rules there. So, and we work on that. So we increase them, we help them to identify, are these the right rules? Is that the right approach that you've done in the past? Is it from, let me use a different word, a model management perspective, still something that should be alive or should be refreshed, refurbished? We bring some kind of an automatism for that keeps an eye on that. And the same with anomalies and modeling. So if the number of approaches increases within your agency or within your company, and the more rules you have, the more models you build, it's not feasible and not handable to do that on a manual way to keep that all alive. And therefore, the approach is to bring that all together with a model management that really keeps an eye on it and helps you to keep it state of the art.
Okay, thanks.
Okay, now I brought 3 visualization examples for you because we talked a lot about theory and how to build network, and here I show you some kind of networks and what they mean. So you have here, for example, a centrality of connecting elements. And what we did here is, and you can see that with the icons, we selected email addresses and telephone numbers within a network center and showed that there is a significant number of connected debtors, for example, without any family connection. And especially, they have all the same addresses, or all the addresses that we see here are from the same area in Germany. And the picture on the bottom left shows it's close to Switzerland as well. So what you see here, there are a lot of addresses, there are a lot of documents, there are a lot of entities that are built and correlations between these. So that builds a network. And within these networks, we have really a significantly high number of connected debtors without any family connection. And that is something worth watching and worth investigating. You might find some indications that help you to find what you're looking for. The next is the IBAN example. So same IBAN, but different debtors. Same IBAN for debtors with different last names was the indicator here. And you can see at the address level that we talk about several cities in Germany, so several addresses across Germany, which are, and if you're not familiar with the distances, I can tell you they're far away from each other. So you have at the top Magdeburg and Schildow, on the right Gelsenkirchen, and at the bottom Oschersleben and Osnabrück, which is quite far away from each other, and you can see that on the map on the left. But they all have the same IBAN, right? And that is an indicator what really should be something that you're looking after, because it looks that we have some kind of organized group here that is worth watching. And the third example is there is obviously one person, but this person has multiple identities. So this case is an application with imagery names and often different addresses, but the connection is done by email, phone number, IBAN, and address. So that's all the same. So same IBAN, same address, same email, same phone number, but obviously shows up with different names. So that's definitely as well something that's very interesting and might be worth watching within your network and do some investigation. And you might have seen in the invitation of Steffen that he wrote something about a case in Austria. And I can talk about that quite often. So the case is the Ministry of Finance in Austria that use with a network analysis tool and analytics exactly the same way that I showed it with the hybrid analytics approach. So they are looking for known patterns, unknown patterns, for text analytics, and so on. And in a very early phase, so there was even a pre-project, a proof of concept or a pilot project, where people have been on the ground from us and people have been on the ground from them, and they built some first models. And at the end of the day, there was a list. There was a list of 10 companies that obviously were very peaking with some activities that don't match to regular activities. And what the Ministry of Finance did at that early stage was they called the police and said, so we have really a high confidence there is something going on. So can you please do me a favor and investigate on these 10 companies? And so we're 10 company names and really 10 hits. So they found obviously what they are looking for, fraudulent activities, tax related, which definitely was 100% scoring, right? And that shows that this approach is something that is really reality based. So this example here, and then we really come close to the end, is as well something that should decrease complexity. It's called Clique Analysis, and with Clique Analysis we mean, for example, lots of entities combined that you can combine again together in bigger networks. So you have some kind of small networks, you combine them to a bigger network, to decrease complexity, because you say they are so similar to each other, this network, and this network is so similar, let's build another network, because this clique analysis is from the inside out, it's comparable. And that helps you when you think about the supercluster with just a huge ball, helps you to decrease it to really more stuff that you can visibly get and investigate. So in the end, the usage is some kind of splitting and reduction of complexity. So the complete clique here can be considered as a single node, and that's helping you. So why visualization? I guess that's quite easy to understand. It simplifies visualizing networks. Simply visualizing networks is not sufficient. So you can expand it manually and then visualize the nodes and the edges that are between that. And active elements that represent entities can be monitored, which is necessary for you if you work on fraudulent activities. And then you can integrate it even in a workflow. So what comes out from the network can be in a regular workflow, can regularly be monitored if something in the network is changing, if it stays consistent, if you should adopt it to new information, to new data that you get. So it's a living process that we're talking about here. So in the summary, it's quite easy. It's only one slide. If we combine network analysis and artificial intelligence, you generate in the end well-structured networks with only good entities. So you decrease the Max Mustermann effect. You have active visualization to bring networks alive and keep them alive. Structures become visible and analyzable. That is something that you haven't had upfront. So you get something visible that you haven't seen before. And the derivation of network characteristics is something that you can use for your analytical procedures. And that's all the stuff. So that is what I wanted to present you today. How to make raw data, how to bring raw data to life with some kind of meaningfulness, combine that with intelligence, and then increase your knowledge for what you're looking for.
Awesome. Thank you very much, Patrick. It was an awesome presentation. I have a few questions, and please just remind the audience you can ask your questions. Use the Q&A section, click on the icon for Q&A and put your question in there. A few things here. So if you go just back to maybe slide 37, which is about the centrality. I think one of the first example we actually made. Just going back some slides. Yeah, maybe this one here. Oh, just forward again.
What slide?
37. I think it was 37.
I don't see numbers here. So what was the content?
Can you move forward? Yeah, let's take this one here. Yeah. So looking at how those nodes and edges are constructed, people are actually connected with using email addresses, telephone numbers, right? Yeah. So these are the connection points. If you go forward a little bit. So this again, this is the IBAN number, yes, the account number from banking, which connects. And I think it was the next slide where you actually talk about, or the next one, about clicks. Yeah.
And that's this one, yeah.
The Clique Analysis. If you look at those things, what kind of data is really behind that? So how can you decide what kind of groups of people have a higher connectivity to each other than others?
Mm-hmm. Yeah. So what you do with Clique Analysis is, for example, so you see here, that is really a simplified visualization, right? Can you see my mouse?
Yes.
Okay. So this here is one network.
Yes.
This is one network as well.
Okay.
If they are similar to each other because of meaningfulness and insight, you can combine them as a clique, for example. So let's say this is the IBAN number from somebody or from a group of people sharing the same IBAN number at Commerzbank, and this is Deutsche Bank, and you just want to bring the complexity down, you can put them together and say, just related to IBAN, they are similar, and I want to do a clique analysis. And then you do the same, for example, with people that share the same identity and put them together. And then you decrease complexity again a lot. And it, in the end, comes down that you see one person with multiple identities plus sharing different IBANs could be an indicator, because what you want to do is, we have huge visualizations. You want to make them as feasible and as easy as to understand as possible. And therefore we use this clique analysis. It might make sense. It's not necessarily that you use that, because what you can see here, it's just a splitting element to reduce complexity. And it's an active work with these networks. Sometimes it makes sense to say, okay, well, let's put that together, and it still makes sense. Sometimes it doesn't make sense.
Got it. Yeah, thanks for the explanation. It was just, and I think it was pretty much in the beginning of your talk today, when you were talking about factorization of networks. That was the term you used. That was just like, of course, it made click for me. So looking at that factorization of networks. So first of all, you just try to use the network itself and the metrics, I guess, you can get from networks to use as factors in something like machine learning, right?
Yes.
Do you have some examples what that could look like, or how that might bring in business value, so to say?
How to start with combining networks or build networks? Was that the question?
Yeah, I was looking at the factorization of networks. Yeah. So, I mean, you can look at it, you can do the metric stuff like closeness, betweenness, the eigenvector thing, and which is interesting. But you actually, in the way you framed it at the beginning,
yeah.
You actually said this kind of information could be an input, could be a factor, and doing factorization of information. That was interesting to me.
Yeah. Okay, maybe let me show you one different slide.
Yes.
It is in German, but it's very easy to explain that. So it's just a different point of view. So you can see that slide?
Yes.
So you have different data sources on the left, which are transactional data, geodata, public data, social network data. And with social network, I really mean the social networks that you know, like Sing, LinkedIn, Twitter, Facebook, and so on. You get them in batch or you get them in real time, doesn't matter. So what you do here is a classic ETA process. Like you read that, you some kind of clarify, is that valid data or not, you combine that, and then you come to the point where we have the 3 steps of event, entity, network, right? So that is just the result of data integration. And the data quality aspect, I showed you with the fuzzy match algorithm. It's a combination. And with the hybrid analytics, you build some kind of knowledge and make a risk assessment. How valid is that? And that is a constant machine learning process that is always evaluated. Like build a model, evaluate that, and it's only working. And that is something that I missed so far. I mean, I should explain that again. So you see on the top right that you get, as an investigator, you get some kind of a surface where you bring your own knowledge into the game. So for example, a police officer gets some kind of a list he should work on, and then he says, that was the right suggestion, a wrong suggestion, and so on. And the machine starts learning from the personal knowledge of the investigator, because the system can only be as good as the investigator. So what we face is we have a lot of experienced personnel, a lot of experienced tax investigators, police, law enforcement investigators. And what we do here is we help these guys with this tremendously emerging amounts of data that they get, to get rid of that and shrink that down to the essentials. And what they do with the surfaces, they say, yeah, that was the right suggestion, was the wrong suggestion. These models behind that evaluate permanently, am I doing, as the algorithm and the network analysis, am I doing the right approach? And that is the factorization because of the learning effects that we have here.
Got it. Thanks, Patrick. In the meantime, we got 2 questions, and I would like to just read them out loud. The first one from Lily. Hey, Patrick, I have a question. First, thank you for the presentation. It was very informative. But I'm struggling with putting this network analysis into practice. It's a data question, basically, right?
Yeah. Yeah.
Especially when you look at one maybe large financial institution.
Yeah.
Normally, you have only a few data about customers, e.g. retail banking, or also when they come from foreign countries like Russia, Saudi Arabia, or somewhere else.
Mm-hmm.
How do you get all the information, the data to find networks? When you think of fraud, persons use different bank accounts at different financial institutions.
Yeah.
So there's no link. You usually get one data from one financial institution, maybe with similar names or addresses. But to find that entity, you only can do that when sharing data between companies. So how does that work, actually?
Yeah.
How can we solve that problem?
Yeah. So that was some kind of the spoiler I made in the beginning, that I said that it's very much public related here, because public authorities have a lot of more of possibilities to get data and work on data by justification. So there is some kind of a threat, and then the data protection is not valid anymore, and they can work on more stuff that usually a bank can work on. So in banking, it looks slightly different. We use systems similar to that for anti-money laundering and know your customer. So that is the mainly use case here. And anti-money laundering is something where we find the detections within the transactions. So it's more transaction based than, for example, telephone number based or stuff like that. But you can see, for example, from different lists that you can get, like public lists. So we talk about companies here, Dun & Bradstreet and all that stuff, trade registers and stuff like that. They share even the same IBAN number as well. So we find solutions like this more in the space where somebody looks after companies than after private persons, to be honest, in banking, right? So for the individual person, finding the individual fraudster, that is some kind of appropriate. But mainly when we look at finance, at Ministry of Finance, for example, tax authorities, banking, they mainly look for companies that are fraudsters. And there, the data sources are more legible and more approachable than for private persons, because you have more registers that you can look at, money house and all that stuff.
Lily, I just allowed you to speak. So do you think the question has been answered? Or do you have additional questions? You're allowed to speak if you like. In the meantime, I have a second question from Iru about the fuzzy matching logic, right?
Yeah.
Is it the fuzzy matching among entities based on NLP or using graph-based analytics, or a combination of them? So to say a hybrid approach.
It's as well as a hybrid approach. So what we look here is some kind of the phonetics in 30 different languages, plus some kind of graphical knowledge, plus really the roots of what we do since 44 years is mathematics. So really do a mathematical approach to, and that is some kind, is really interesting. So when you look into text mining solutions, there is a difference. There's a huge difference. So you can do it either graphically or phonetic, or you can combine it and then do mathematics on top and calculate distances between words, between the phonetics as well. And then you get some kind of an on top knowledge that helps you with the sensitivity score and helps you to increase that. And that's really interesting.
Yes, sounds pretty much interesting, I have to admit as well. So looking at, I think all questions have been answered. Patrick, I think, again, I want to say thank you. I saw also people saying thank you in the chat. Some people had to leave because we had a meeting, but just ask if there will be a video available. Yes, the session has been recorded. So maybe you want to replay it because maybe you just missed something. And also I'm going to upload the presentation, so everything will be available at your hands. Thanks again, Patrick, for joining us today, for willing to present here in front of the audience. From Peter Chandis comes also many thanks. So just I'll give it back to you. And thanks to the audience for joining us today. Hopefully we can meet virtually at least next time in the next meetup. I say goodbye, and whatever daytime it may be, as here it's getting late night here, late evening. Enjoy your evening, enjoy your morning time, afternoon time, whatever it is. Have a good day and stay safe. Thank you and bye-bye.
Thank you, everybody. Thank you for listening. Bye-bye.